Alright, so here's another 3 by 3 system that we need to solve. And again, the goal is to create a 2 by 2 system by choosing which variable I want to get rid of, and then using that variable to get rid of the other two. So again, you can choose whatever you would like. What I'm going to go ahead, since I have a nice x out in front here, I'm going to choose to eliminate x, and I'm going to use this guy as my pivot. So I'm going to use this x to get rid of the other ones, right? And so here's equation 1, here's equation 2, and here's equation 3. So how do I do this? Well, I need things to be opposites here, right? So this is 2 and that's 1. So I need to take negative 2, I'm going to multiply it to equation 1, and then eventually add that to equation 2. And that'll give me what I need. So following through on the math, if I multiply everybody up here by negative 2, we end up negative 2x minus 4y minus 6z equals negative 12, right? So negative 2, negative 2, negative 2, negative 2. Take that and add it to equation 2. So 2x minus y plus z equals 3. And so when all is said and done here, right, the x's do cancel out. We have a negative 5y minus a 5y, and that looks like it's going to be, let me make sure I did my math right. Yeah, so that looks like it's going to be a negative 9. So if I at least divide everybody through by a negative 1, right, we get, that's a z there. We end up with 5y plus 5z equals a positive 9. So there is my start. All right, so doing some row operation math, or what I call equation math. So the next one, so I want to get rid of this 6x using that. So I basically need this to be a negative 6. So I need to multiply negative 6 to equation 1, add that to equation 3, and I get what I need. So doing that, I get negative 6x minus 12y minus 18z equals a negative 36. I think I did that. Negative 6, negative 6, negative 6, negative 6. Add that to equation 3. That's 6x minus 3y plus 3z equals 9. So going through all of this, right, the x's cancel out. We have negative 15y, right, minus 15z. And out here we end up with a negative 27. Okay, and what I can see, how about we divide everything out by a negative 3? And when I do that, what I end up with is 5y plus 5z equals 9. And that's pretty surprising there, because, right, what we end up finding after that round, right, this and this are basically the same. So here's what this basically means. All right, what this basically is telling us is that there is a solution. We are consistent, but this time again we are dependent. All right, so so once I find one variable, that value is going to drive another variable and what it's going to be. So we might as well start with what we have here. So since we know that 5y plus 5z is equal to 9, right, how about I just go ahead, you can solve for whatever you want, but let's go ahead and solve for y. So I'll subtract 5z from both sides, and we get 5y equals negative 5z plus 9. Divide both sides by 5, and we get that y is negative z, right, plus 9/5. So there is y. Okay, and so I can now use this because it looks like, right, we have y depends on z. So z is the guy that's determining everybody else. If I can find z, I can now find y. So let's go back, right, and find this all out. So how about we go to any one of these will work. So why don't we just go to this top one here. We know x plus 2y. Gosh, I hope I I think I lost you guys there. I'm sorry about that. I wasn't paying attention. So I chose this function, right? It's the same one. So I basically solve for y. And so what this is telling me is that z is the kind of the independent variable. So if I know z, I can use this equation to solve for y. So y depends on z. So we're consistent, but we have a dependency. So there's not a unique system, right? Because already if I let z equals 0, we get that y equals 9/5, right? If I let z equal 1, right, then I'm going to get another value for y. So we can see there's several solutions. But now what we have to do is go back and find out what x is. So using any one of these equations, I'll use the first one. If I now substitute what I know for y, this is x plus 2 plus 3z equals 6. Substituting what we know, this is negative z plus 9/5, right? What we end up with is x minus 2z, right? That looks like it's going to be a plus 18 over 5 plus 3z is equal to 6. So this is x plus z, and if I subtract 18 over 5, we get 6 minus 18 over 5. So x plus z, this is 30 over 5, that's 12 over 5. So x is negative z plus 12 over 5. So again, you can see that if I let z equal any number, right, like for example, if z is equal to 0, y will be 9/5 and x will be 12/5. But if I let z equal to 1, I'm going to get different values. If I let z equal negative 1, I'll get different values. So this is what we call a consistent system, because there are solutions, but they're not going to be unique because variables depend on other variables. Again, the way we would write this as an ordered triplet, I would say this: z is itself, right? Z can be any number that I want. Y is negative z plus 9/5, and x is negative z plus 12/5. Okay? The only thing that can possibly change here is, keep in mind, I chose to eliminate x. If we'd have chose to eliminate y, then everything would have been dependent on y. Y would have been y would be the, if we'd have chose to solve for, get rid of y and maybe use that as a pivot, then what would have happened is that y would be the independent, and then z would depend on y, and x would depend on y. If we'd have chose to get rid of the z, right, then we could have gotten to that address. We could have gotten things into another one. So again, there's multiple answers here. It just kind of depends on who you want to get rid of, and eventually who do you want to solve for. Because I could have very easily taken this equation and solved it for y, right, and then made y the dependent, and then y the independent. Y would be by itself, z would be in terms of y, and x would be in terms of y. It gets to be crazy, and that is why we eventually step away, right, and we end up using another thing called matrices. All right, so it gets very, very messy. 2x2 systems aren't too bad, but once we get higher, trying to use substitution or elimination with things that are 3x3 or higher, it just gets to be a train wreck. All right, so that is why we're going to learn some new methods, but this is what we got out of 12.1. So practice, practice, practice. All right, if you have questions, post them on Canvas. Let me see your work. Let me make some suggestions. All right, see me during an office hour. Whatever it takes to kind of get all this down. The key word here, the buzzword I'd have to say, is just try to keep yourself organized. I hope I was a relatively good example with my notation, moving some things around, all right, because it gets really, really messy. So thank goodness for calculators and matrices. We'll see soon. Otherwise, that wraps up 12.1. I'll see you guys on Canvas. Hope to see you for office hours if you need help. Take it easy.